Alrighty. Hello, everyone. My name is Ian. Joining me are Joe, Emily, and Mahesh. Today we have an AppSec-focused presentation about making a next-generation static analysis security tool. Is that what that acronym stands for? I promise I'm an AppSec engineer. So here's the industry standard like SDLC process. Basically, we have threat modeling. We have two very common business acronyms for security tools, namely a static analysis tool and a software composition analysis. These are basically like scanners on code bases and then scanners on dependencies. There's also dynamic application security testing. That's stuff that's a little bit more like automated pen testing or red teaming. And then the last part of the pipeline is sort of the incident response or monitoring so that when somebody hacks into your stuff, you actually know what's going on. So today we basically started from there and figured out, hey, how can we throw an LLM into this mix to try to sort of automate our job a little bit? So we've got a very old open source Google web application called Gruyere, which is a type of very delicious cheese. And we are running it through a bunch of tools, namely an LLM-generated threat model, a repo map that is basically just a list of function signatures. We're taking the diff out of a GitHub PR and we're running that through GitHub. We're bundling this all up together, passing it through an LLM using a couple of standard tools, and then generating a bunch of recommendations, fixes, comments, and line numbers. So this is the basic shape of the code. We're starting with Gruyere, and we're generating that list of recommendations. And then we have this sort of pseudocode for a Python block, which is running in CI, that's basically taking these couple of inputs. This is a screenshot of Google Gruyere. It's very cool. I think it was originally made by Parissa Tabriz, who I think is still the head of Chrome security or something like that. I don't know. I haven't looked at it since university. But it's well-documented Python. Here's a spot the bug exercise. I know it's a lot of text, but I don't know if anyone really likes reading Python. There's a subtle, not so subtle, privilege escalation here. I don't know if anyone wants to like shout out what they see, but is there anything, if anyone just wants to shout in the room, like what seems sus about this code? I'll give y'all a hint. Admin is a query parameter. Yeah, so if you look way down, next slide, at that very bottom line, you'll see the database has an update with the profile data, and that profile data object is built up at the top with the user-controlled isAdmin parameter. So if you visit this URL or send like a GET request to it, it's going to construct this object and then update the database row for that user to have isAdmin equals true. So bog standard, terribly written, deliberately vulnerable web application. You visit this URL. Can we detect this with LLMs using the standard AppSec process? And so let's say that we have some lovely AppSec engineer inside of your organization, and they think that they've spotted a bug here because it's their first day, and they've made a fix. And so normally the way that this might go would be that two humans look at it, somebody reviews the PR, okay, it gets commit, and everything's fine, right? So what if we throw LLMs into the mix, something akin to a standard tool? Joe and Emily have this. Can y'all say something about what this is? I'm not sure.
So we have been building out an automated threat modeling tool. So it will go through the entire code base of Gruyere and kind of talk about all the different vulnerable code in the system. The idea is to give more context behind the static code analysis than just like looking at one line of code, and instead be able to have actual diagrams of the architecture and threat modeling. So that's all of this is going to be dumped into our larger LLM context along with the PR.
Yeah, and so they've built this kind of cool thing that takes the code base and produces a threat model. And so here's the code that we wrote today. This is the meat of it. Basically, it's taking in that threat model, this map of the repo, the diff from the PR, and the output of semgrep. And then we're shipping that all off to an LLM, running this basically inside a GitHub action on a PR or push to a branch. And it's coming back with this. This is LLM output right here, which is noting that the fix was incomplete on the admin functionality in this web app. And it's suggesting a fix that would more completely fix it.
So should we show the live demo again?
Yeah, live demo. This is like plain text threat model. That looked like a diff. That looks like samgrep output. And
Final output.
nice. So piped off to an LLM, made beautiful with some nice highlighting. And we've got some XML that you can throw into a GitHub PR or some kind of dashboard or a tool that some engineer would then look at and then go fix.
We built this whole script today.
Wow.
Yeah.
Wow.
Look at us go. Cool. What slides do we have left? So yeah, so remembering that PR comment from earlier, what if instead there was something which hopped in and took a look at some code and then I guess filled up the LLM's context window in kind of an intelligent way and then tried to spot bugs basically that maybe engineers would miss or maybe just help engineers work faster. Cool. And here's some future work. I think the big part of this is, yeah, like how do we help engineers get more efficient at just the sort of standard AppSec process? There's a lot of, I guess, like the sort of standard like scanners that people use. I really like thinking about Stable Diffusion and DeepSeek R1. So if anyone wants to talk about either of those, I know a little bit about how Stable Diffusion works. Mahesh, Emily, Joe, do y'all want to comment about like what that future work looks like?
We're building this for real. If this is super cool for you and you want to also build it, you can come and talk to us.
Hey, so just a quick question, just so I understand, some of the differentiation here is it's not just about scanning the code for the vulnerabilities that you would find, like semgrep or sneak would find, but also the fact that you created this more threat modeling in this graph-like view that you're then feeding that into the context alongside of these issues to get an overall assessment at the end. That's the real differentiator, right?
Yeah. So one of my favorite mental models with LLMs is that like garbage in is garbage out. So diamonds in is diamonds out. And so Mahesh and I have been AppSec engineers for, I don't know, between us probably over a decade of professional experience. So we're leaning on all of that in order to have a sense of like, hey, what are the inputs that we would pass off to a human that would help that human focus on what really matters?
Yeah.
And so basically we're trying to crystallize that sort of, you know, these things that we know mixed together with what Joe and Emily have sort of built already. And yeah, so trying to figure out some way of phrasing all of the input to the LLM that'll try to produce outputs that are a little clearer.
How many people on your team? Four. Man, okay. Yeah, you guys did all that today, right?
The Clearly AI UI that you saw that generated the initial threat model with it today.
Okay. Is Clearly AI your thing or that's another? Oh, okay. Awesome. Thank you.
Yes, question in the back. Hey, do you guys actually write exploits to validate the bugs?
We don't currently write any exploits. I'm also an AppSec engineer by trade, so less offensive, but we do write pen testing plans based on the threat model.
Question in the back.
Two questions actually. Call flow, you're only deriving that from your SAST, right? Or is there another way that you're deriving call flow?
Like for a data flow diagram?
Yeah.
So the data flow diagram, in the threat model is generated entirely from the artifacts that are uploaded for the threat model. So for this, we just uploaded the entire Gruyere code base to the Clearly AI tool to generate the data flow diagram.
Right.
So that's outside of semgrep.
And then the actual threat assertions in your threat model, what were they? I missed it.
So we did assert from the escalation of privilege side. Let me see. Yeah. If you go down to escalation of privilege, they were. I don't think it's that one. There was like hard-coded, the one that we passed in, Joe, was Gruyere test 1.
But you're, so I saw those like in the table there, it says
Mhm.
like hard-coded credentials.
Yeah, it's like lack of role-based access control, hard-coded IP whitelisting, weak cookie management, inadequate input validation.
Are you finding that, from an audience perspective, people that maybe deal with weaknesses might misrepresent those threat assertions as weaknesses?
Can you rephrase it one more time?
So
Sorry.
those threat assertions that you had on the table, do you find that a lot of your audiences are misunderstanding the threat assertions to actually be weaknesses in the application model?
Are they as fine? Are you saying like, so what we do is we have like existing mitigations to the threats and then propose remediations if there aren't existing mitigations. So I guess the threat assertion is a weakness if there's no existing mitigations on that threat. Does
Okay.
that answer your question?
Yeah.
Okay.
Yeah.
Sorry.
You're clearly AI. That's a security product you guys built.
Yes.
So that's sort of the backbone of what you guys have
Of
built
the
in this project.
threat model,
Of
and
the
that's
threat
it.
model.
So we uploaded the threat model as piece 1. Piece 2 was a repo map that we got from Aider.
We tried to get the repo map from Aider, but we found it easier to just use tree sitter to generate a repo map in this case. But yeah, just want to make sure, like, to clarify that we were only using like the threat model output document as one of the possible sources for the tool that we built today.
Right.
Yeah.
Got it. Thank you. One behind you.
Sorry, I just have a question. Can you go into more detail how you use tree sitter and modeled the code as an AST?
We used Cursor to, honestly, it was the first time using it. So Cursor was just a great way to like get a very basic integration with tree sitter going. And it was a very simple, just look at the file names, class names, function signatures,